So here I'm logged in the Microsoft Azure Machine Learning Studio. This is my workspace. And what you see here is mainly the canvas, as they call it, which is where you drag and draw modules here from your left-hand side, and you build your own pipeline and configuration. On your left-hand side, you have the navigation pane. You can collapse or expand this menu. You can see here how you can navigate across projects, between projects, experiments, web services, notebooks, data sets, train models, and settings. Here on the bottom bar, you can see the running history, save your current experiment, run the whole experiment, or select modules as you can select. And you can also set up your web service. Basically, the whole philosophy is that you drag and drop modules, and then you connect them by drawing these connectors. And each module will behave differently. Another very interesting aspect is here on the left-hand side. You can see how rich this menu is. So you can see data format conversions, data input and output, things like machine learning models, evaluation modules. You can do cross-validate, initialization, where you get all the actual algorithms. So let's say for classification, in my case, I used a two-class support vector machine and a two-class neural network for the purposes of this experiment. But obviously you can see there are quite a few. Most importantly, you can drag and drop and build your own Python and R custom scripts. And I've used some of them, but I will show you. And this is the overall, I guess, layout of the screen. What I'm going to do now is I'm going to explain step by step my experiment. So the first thing you need to do is you need to add a data set. In order to do that, you go to the New button, click that, select data set, and then from local file. And after you upload the data, then you can access it from here. If you go to Save Datasets, My Dataset, this is the one I used, Training CSV, you just drag and drop. Obviously I have it already here, that's why I didn't do anything now. So this is my initial data. You can visualize things by right-clicking, select the dataset, and then visualize. So if you want to see how this dataset looked like, this is what it was like. You can get some initial statistics and views, and you can change the view in a box plot if you want. Okay. So you can see here, for example, in the dataset, what is the step-by-step guide to invest in share market in India? What is the step-by-step guide to invest in share market? And you see that the label that Quora is giving is 0 because this is not a duplicate question, and your model is expected to understand these differences. On the contrary, if we find this example, which talks about astrology, I am a Capricorn, Sun, Cap, Moon, and Cap rising. What does this say about me? Or I'm a triplet Capricorn, Sun, Moon, and Ascendant in Capricorn. What does it say about me? This should be treated as a duplicate question pair. So I load my data, and then I build this custom R script. It's very easy to do. Basically what it does is it concatenates the text from the two questions, so I merge them into one, so that I need something to work on. And then I separate the label and the questions texts. I do some pre-processing. I replaced all the punctuation, special characters, and digits with space, so that my text analytics algorithm performs more properly, and I convert everything to lowercase. And then the output of this script will go into this field, which is called edit metadata. And what it does is you can basically edit specific metadata. In my case, I made the questions text column as a non-categorical string because it might be considered that that's a categorical one, and you don't want to do that with free text. Just to show you how you can configure this module, for example, you select and then click Launch Column Selector, and then it allows you to say, okay, with rules, include all columns or no columns, and specifically choose the ones that you want to add in this configuration. Okay, so after we do that, then one of the most important things in this experiment is feature hashing. You can see that Azure ML, as part of this module, offers feature hashing to convert text data to numeric features using the Vaupal Wabbit library. This is basically where the free text from the merged question field turns into a quantifiable feature, actually to numerous quantifiable features. In this example, I ended up just using a hashing bit size of 17 and n-grams of 2. N-grams, by the way, is where you want to model unigrams, bigrams. In this case, it's up to bigrams because it's 2, but you can go to trigrams and things like that. And the hashing bit size is the number of bits to use when creating the hash table. By the way, it's worth mentioning that I've used the free subscription, and this has specific restrictions on the time that you can run an experiment for, as well as the number of rows you can pass through processing. And obviously, this has limitations on how far I can go with my experiment. I would expect a paid subscription to allow to build even more complicated models and get even better results. So the output of this module is a transformed dataset with thousands of hashed features. Azure ML will not allow me to visualize this specific dataset due to size. I still think that a paid subscription would allow you to. Now, what I do is I split the data. I do a random stratified split on for train and test. Now, you might remember that the Kaggle website also offers a test CSV file, but this one, A, is too large for the free subscription. It's more than 2 million question pairs. And B, it is unlabeled. Kaggle doesn't give the labels on the test CSV file so that they can use that to measure the accuracy and performance of your model when you upload it to the website. So in this case, I did a 80% to 20% split, 80% to train my models and 20% to validate their accuracy and other metrics. Then what I do is a filter-based feature selection, which I found quite interesting. I found it actually from other tutorials, but basically what this does is, after you hash all your bigrams and stuff, you end up with lots and lots of numerous features, and you really want to keep a number that makes sense. Here, our limit is to 20,000, and it keeps the ones that fit better for the models that have better results. Again, if I had a paid subscription, maybe I could have tried going with even more features. Finally, I start adding the models. This is a 2-class support vector machine. You can configure the parameters here, and the 2-class neural network. This is the initialization of the model. You just need to add this module, which actually is the one that takes most of the time. For the support vector machine, it took about 57 minutes. For the neural network, it took about 26 minutes. But this is not consistent, so in some runs, the elapsed time would slightly vary between the two. And after you train the model, you basically score. By scoring, we mean you make the predictions. Here, what we do, so for example, is we take the trained support vector machine and run it on the 20% test data that we get from the split of the initial data set. And the same applies for the neural network. And what this does is, let me show you the outcome, for example, of this one. So what this will produce is it adds 2 new columns in whatever you fit it in, and these are the scored label, which basically is the prediction of whether this is 1, which means it's a duplicate question pair, or 0, which is not a duplicate question pair, and the scored probability, which basically is a number between 0 and 1, after taking the model into consideration, you end up with your score probability, and if the score probability is above a certain threshold, then this ends up being a positive class. If it's lower than that, it ends up being a negative class, like 0, which means that this is not a duplicate question pair. And this is what the output of the scored model module looks like. You can see here you have like 20,000 features plus some other statistics. Let me close that one. And after you get the score predictions, you can run the evaluate model module, which actually compares the two. What it does is, for each one of these ones, it will take your prediction, the scored label, and compare it against the duplicate label, which was the initial label in the trained CSV dataset, and it will actually measure how many of these you got correct. You have some nice visualizations here on the evaluate model module, which I'll be showing now. You can see how it provides a ROC curve. The blue one is the support vector machine. The red one is the neural network. You can see that it's slightly better than neural network. You can also get some other metrics here, like precision, recall, F1 score, your true positives, and stuff like that. Now, if you click the setup web service, then you get the option to deploy the web service. And after you click that, you end up with an automatically deployed web service that you can see here. You can see some difference basically, and the main one is that because this is obviously your operationalized or your operational web service in production, you only keep to use one model. So in this case, you might see this one, which is the trained model from the neural network. This will be done automatically, by the way, from your experiment after you click the deploy web service button. But you also need to make a few differences. The other one is, for example, where does your web service input coming in? I know, for example, that when we want to do the predictions for Quora, we won't have the same columns that we had in the initial training set. We won't have a label, for example, or we won't have a question ID. So we only have the text from the one question and the text from the second question. So you can do some filtering here. The trained CSV is still kept here because the system wants to know the initial schema. And you can see how we only use this model. Again, you need to do some filtering because in my output, basically all I want to see is the result of the prediction. I don't want to see all the 20,000 hashed features, and you can do that with a select columns dataset piece. And so after my web service is deployed, I can go here to my web services, click on it, and then this offers me the configuration screen and the dashboard. It gives you the API key, which you need to use in your own app or script if you want to connect through this. You have two modes: request response, which is basically ad hoc querying by the web service, or batch execution if you want to load a long file with maybe question pairs and you want to get a result. What I found was that the documentation here is quite outdated. So if, for example, you go to the batch execution, you will see how Microsoft provides some good documentation here, but also sample code down below in C#, Python, R. So in Python, if you copy paste that and you try to use it, it won't work. This uses some packages from the Azure SDK for Python, which are obsolete. They have changed, so you need to pay some attention there. But basically, the rest of it works fine. And I can test my model and web service by clicking here. You see now it gives me the schema that I have designed it to, just two questions. So let's say, is Paris the capital of France versus is Paris the capital of UK, send that to the web service. You see, it's running my model now. There's the result. It's not a duplicate. The probability is 0.44, which is less than 0.5. That's why it gets 0. Finally, with regards to visualizations, I developed a couple of Python scripts to reflect on some metrics that I believe provide some good insights. I had to add a few new modules that you can see here. But basically, I wanted to select specific fields like questions, text, scored level, and scored probabilities. And then I wrote a custom R script for each of the two models that basically what it does is it counts the number of characters in each merged question because I wanted to check whether the models are being affected by actually how long the question strings are and whether it affects the predicted value. And here you can see this is some visualizations in Python. You can see how the support vector machine for all question pairs that the combined string is over 300 characters, it will always give a 0 result. So it will never count them as a duplicate. Whereas the neural net will still score a few above 0.5. And I think this is an interesting finding. It seems like also here in this area, over 260 perhaps, neural net will still find more duplicate questions, and maybe this is what is reflected in the evaluation results as well. So this is it really. Azure Machine Learning is definitely a strong tool. It allows building machine learning models in short time frames very quickly. It feels like it is more suitable for running standalone experiments, and maybe if used in production, it looks more appropriate for running predictions in batch rather than in real-time streaming types of applications. But overall, I think very nice tool, very intuitive, and very powerful. That's it. Thank you very much for watching, and please feel free to comment if you have any questions on this. Thanks.